For our microservices to be able to communicate with each other, each microservice needs to have an address. But how can we find out what address all the other microservices are located at? Let's imagine we've got 3 virtual machines and we've got various microservices running on each machine. Maybe we've even got multiple instances of some of the microservices running on different machines in our cluster of virtual machines. Now, we don't want to have to hard code IP addresses in, as that gives us poor flexibility to dynamically move our microservices between virtual machines in the cluster, which is necessary in the cloud, as machines do need to be taken down from time to time for servicing purposes. Now, there are a few ways that we can solve this problem, and one is to make use of what's called a service registry. This is a central service that knows where all the other microservices are located. Sometimes this works by each service reporting its location to the service registry when it starts up, and keeping in touch to allow the service registry to know that it's still available at that address. That means that whenever you want to communicate with another microservice, you can ask the service registry to tell you where that microservice can be found. And the service registry itself is typically distributed across all the machines in your cluster, which makes it simple for you to be able to contact the service registry. But you don't necessarily need to build your own service registry. A number of microservice hosting platforms solve this tricky problem for us by means of DNS. For example, if you're using a PaaS platform to host your microservices, then often each microservice you deploy will automatically be allocated a DNS name that points to a load balancer sitting in front of the actual instances of your microservice. And that means you can just use the DNS name to communicate with your microservice and not have to worry about the actual IP addresses of the individual virtual machines that are running the service and might change over time. Or if you're using a container orchestration platform like Kubernetes, then you can simply refer to the other services just by their service name. Kubernetes has got its own built-in DNS, and that means you don't need to know the IP addresses of each container. You just need to know the name of the service you want to talk to, and it takes care of routing traffic to the container that's running your service, and load balancing if necessary. So the challenge of service discovery tends to be much easier if you're planning to host your microservices application on a modern, microservice-friendly platform. In this module, we've learned about several different ways that microservices can communicate with each other. There are no hard and fast rules about what you have to use, but 2 of the most common mechanisms are implementing RESTful APIs, which allow your clients to make synchronous HTTP calls to your microservices, and publishing messages to an event bus, which allows asynchronous communication patterns. And these 2 approaches are not mutually exclusive, and it's quite acceptable to use them both in the same system. We also learned about the API gateway, or backend for frontend pattern, where we put an intermediate proxy between our front-end applications and our back-end services. We also looked at some techniques that support resilient communication patterns, including the use of retries, circuit breakers, and caching with synchronous communication. And for asynchronous communication, we saw how we can take advantage of message retries and that we need to make sure our message handlers are idempotent. Finally, we learned that service discovery can be implemented using a service registry, and that many modern PaaS microservice hosting platforms and container orchestrators like Kubernetes can solve this problem automatically for us, making our lives much simpler. Now, we've not yet discussed the very important problem of how to secure our microservices, so let's look at that next.